All right, guys, let's start the review. So, tomorrow should be the start of it. Yep. So, when we look at the review sheet, the first one, problems 1 through 4, which of the 4 quadrants does each angle lie? So, if we remember the unit circle, and again, you can have the unit circle on your test.
Good afternoon, Crawford High School. Seniors, please turn in your baby photos to Ms. Bruckner. If you have any questions, please reach out to her. Congratulations to the following students who were selected to serve on the Grant Savings Bank Board: Haley Wardlow, Lara Thurman, Cooper Mont, Malachi January, and Peyton Bailey. Seniors in homecoming need to turn in their write-ups ASAP to the office, and we need the following students to come to the office: Raylan Matney, Mason Arkell, Sydney Lohr, Stormy Morris, Blazon Blackman, Jimmy Hamilton, Ethan Russell, Crystal Rodriguez, Allie Joe. Hunter Barr, Juliana Dietrich, Destiny Jones, Kiana Brown, Colton Martin, and Damian Andrews. Thank you.
So, quadrants, 1, 2, 3, 4. 360. Because it's going to be in 1, 2, 3, or 4 quadrants. 1, 2, 3, 4. And we need to figure out where each angle lies. Now, quadrant 1 is going to be between 0 and 90 degrees, or 0 and pi over 2. Quadrant 2 is between pi over 2 and pi, or 90 and 180. Quadrant 3 is between pi and 3 pi over 2, or 180 and 270. Yep. 180, and then the last quadrant 4 is between 3 pi over 2 and 2 pi, or 270 and 360. And again, you could use the unit circle to reference this here. But these are our angles, and we're trying to figure out which quadrant each one of them lies in. 7 pi over 4. Because here with our radians, we're trying to see, is it between 0 and 2 pi, 2 pi and pi, pi 3 pi over 2, or 3 pi over 2 and 2 pi. And really with the radians, you can look at them as more their number than just pi, because we have 0, well, 1/2, pi over 2 is 1/2, 1, 3/2, and 2. Well, 7/4 is between 2 and 3/2, so this here is in quadrant 2. The other way we can do this is convert it from degrees to, or from radians to degrees. Well, 7 pi over 4, to convert to degrees, we multiply it by 180 over pi, gives us 315 degrees. 315 is between 270 and 360, so we are indeed in quadrant 2. Questions on 1? 315. Sorry, quadrant 4. Yeah, that was my fault. Yeah, quadrant 4. I don't know why I wrote 2. Quadrant 4. That makes a lot more sense. Yeah. I was pointing at 4 and then wrote 2. Yep. Questions on 1? So if we look at number 2, negative 12 pi over 5, well, one thing that's going to be helpful for us is to get this to a positive angle. And to do that, negative 12 pi over 5, we're going to add 2 pi to it, because we want to try to get this between 0 and 2 pi. It'll still give us a negative angle, so we'll add 2 pi again. 8 pi over 5 is going to be between 0 and 2 pi. Because 2 pi for us would actually be 10 pi over 5. 10 over 5 would be 2. Now we need to figure out which quadrant we're in. And we look at this here, 8/5. Again, we can do 8/5 with this here because 8/5 is going to be greater than 1. It's probably going to be less than 3/2. 8 divided by 5 is 1.6. Our 3/2 is 1.5, so no, it's actually bigger. This would also be in 4, yes. Another way we can look at it, again, I think working in degrees is a little bit easier. 280 degrees is 288 bigger than 275? Yeah. So again, it is.
Hunter Barr, Juliana Dietrich, Destiny Jones, Colton Martin, Damian Andrews, Blazon Blackman, Crystal Rodriguez, and Allie Jones to come to the office, please.
Now, we could have started this problem off and turned it straight into degrees, which is negative 432 degrees, at which point we would add 360 to it. Still negative, add it again, 280 degrees, that is in quadrant 4. So there's nothing that says that we have to keep radians in radian measures. We can convert it to degrees and then find its quadrant. 475 degrees. Which quadrant would that be in? Well, it's bigger than 360, yes? So to get it back into 360 to its co-terminal angle, we would subtract 360 from it because it's too big. We want to make it smaller, which would give us 115 degrees, which would be in quadrant 1, 2. Because 115 would indeed be between 90 and 180, so it is in quadrant 2. Questions? I think with most of them, especially the radians, I'd just convert it to degrees and go from there. Negative 374, is that on our unit circle? No. Do we subtract or add 360? Add, because, well, we need to get it to be between 0 and 360. If we add this here, we would get negative 14 degrees. So we add it again. 6, 4, 364 degrees. Now, we don't have to do that by hand. 376, 74. That's it. Negative 374. So we add 360 to it. Negative 14. Add it again. 346. And that would be in what quadrant? 4. Yep. So with most of these here determining the quadrant, I would just convert them all to degrees and go from there. Questions on this here? 5 through 6. Complement and supplement. We'll do one of each, one in degrees, one in radians. With number 5, you want to do A or B? Okay. Pi over 3 for the complement. Complement, it and the other angle have to add together to be pi over 2. So to find it, we take pi over 2 and minus pi over 3 from it. Pi over 2 minus pi over 3 is pi over 6. Supplement. It should add together to be 180 or pi. So we're going to take pi and subtract pi over 3 from it. Questions on this so far? Now with this next one, pi minus pi over 3, will our answer have pi in it? Well, yeah, it's in common with both, yes, because I'm taking 1 pi and subtracting 1/3 pi from it. So because the graphing calculators can do 1 minus 1/3. it'll do it just fine. Pi minus pi over 3, it's going to approximate pi to 3.141. But if I do it here, 1 minus 1/3 is what? So it should have pi, yes? So it's actually what? 2 pi over 3. Yeah, because with addition, subtraction, because the first one we could have done 1/2 minus 1/3 and got 1/6 or pi over 6. So if you don't have the 30xs, especially with radians, and you're adding 2 radians or subtracting 2, we can just put the numerical numbers in and throw pi back into our answer. Although the 30xs will use pi and approximate it just fine. Questions on this here? All right. A or B? B. So B, complement. So 93 and our other angle should add together to be 90, yes? So we'll do 90 minus 93, which is -3, which means there is none. There is no complement. Because again, it should be 2 angles add together. -3 degrees, especially for these here, does not work. There just is no complement. Supplement. We're going to do 180 minus 93, which is 87. Calculator can do that just fine. The other way to do is add up to it. I don't know if y'all have done that before. If y'all have had to make change, it's the same thing. 87, I had 7, which takes it from 87, 97 to 100. 8 gets us to 180. If you've ever worked the concession stand and handing back change, that's one way to keep track of it. $4 in drinks, so that's 4. 1 gives me 5, 5 gives me 10, 10 gives me 20. Easy way to make change. All right. Yes. The 30xs. If you use the graphing calculator, it works fine. But because the first one is pi over 2 minus pi over 3, it doesn't like pi. It works with pi just fine, but it does not leave it in terms of pi. It's going to want to leave it as a decimal. So I can do 1/2 minus 1/3, which is 1/6. They both have pi, so it's going to be pi over 6. Also, as you can tell, it's a lot easier to put it in the 30xs, because for the graphing calculator, you get your fraction, it's alpha y equals enter. For the 30xs, it's one button. Graphing calculators do a lot of good things, and they're very nice in a lot of ways. But some of these basic calculations, it's easier to just take 30xs and you can type it in so much faster. Give 2 coterminal angles, one positive, one negative. Let's do 7 or 8. Which one do you all want to look at?
Let's do
7. So we need one positive, one negative, yes? It's already negative. So let's do -375. I'm going to add 360 to it. And I get -15 degrees. So there's one coterminal angle. I have my negative, yes? I can add 360 again. 345. Now we didn't necessarily have to add first. I could have started off with subtracting 360. So -375 is a negative coterminal angle. So especially with these on the test, I will double check and make sure that your 2 angles are 2 coterminal angles. So we could have started off, we subtracted, got the negative. Then we added, but it got us -15, not a positive angle, so we added again. All I'm looking for is one positive, one negative. You give me one of each, I will take them. And I will check and make sure if it's not one of the ones I have listed. Because the next one's bigger than 360, I can subtract it, I get a positive. I subtract it again, I get a negative. So some of them, it might take more than one time round. Let's look at 10. 37 pi over, I think it's 2, isn't it? Okay, that seems like a really big angle. I'm going to subtract 2 pi and get. You can list that as your coterminal angle, because it is. Well, it's still positive, yes? So I'm going to subtract 2 pi and get this here. Now, especially if it's really big, I hope you noticed that I didn't type in 33 pi over 2. I just said minus 2 pi and hit enter, yes? There's a reason this is nice, because if I hit enter again, it took the previous answer and subtracted 2 pi. Negative 3 pi over 2. Now, any of those angles, 33 pi over 2 all the way up till we got the negative one, all of those are technically one of the positive coterminal angles. I only need one of them. And then we need the negative. So sometimes we have to add 2 pi or subtract 2 pi multiple times to get the ones we need. Sometimes we just add, subtract, do it once each, and we got the 2. Questions on these here? We kind of like these here. They're not too bad. And there's worse things that you could be doing. Convert from degrees to radians, radians to degrees. Degrees to radians. You take the degree measure, multiply it by pi over 180. Radians, 2 degrees. Take the radian measure, multiply it by 180 over pi. So negative 20 degrees. We'll multiply by pi over 180. Negative pi over 9. Yep. 480. Multiply by pi over 9. Pi over 180. 8 pi over 3. Questions on those two? We're ready for the next one. 13, we're going to degrees. So we're going to multiply this by 180 over pi. And at this point, you can do this in the calculator, let it do it for you. But really, pi is gone. 17 pi over 10 times 180 over pi is 306. Degrees. I think the next one's 10. No, it's not. It would have been nice if it was. So here, pi over 80 times 180 over pi, 2.25. Or 9/4. Just like in Algebra 2, as long as it is the correct answer, I will take it no matter what form, decimal fraction. Unless I specifically ask for a certain answer, so like our inverse trig for this here has to be in radians. Has to be in radians. Convert from degrees, minutes, seconds. or from, so revert from degrees to degrees, minutes, seconds, or from degrees, minutes, seconds to degrees. We're going from one to the other. So the first one, 47 degrees, 40 minutes, 20 seconds. 7 degrees. I think it was 40 minutes, yes? And how many seconds? 20. Go to 4 decimal places, 47.6722. If you wanted to do this, not by hand, but kind of, it would be 47 plus 40 over 60 plus 20 over 3,600. We could type that in and get that there.
Wait, although does this have to be in
Graphing. Yeah. So the degrees, minutes, seconds, or we can just type it in. The graphing calculator will do it. The 30XS might do it. I just haven't taken the time to figure it out. So this here, the mode doesn't matter. Actually, yes. So 40 minutes, 40 second angle degree. Oh no, it's 47 degrees. Second angle. Nope. I got to do the number first. 40 minutes, 20 seconds. And yes, this here, yep, will have to be in degrees. Yep. So the 30XS will do it. It's second angle, second probability, PRB, will also do it.
How do we change that mode?
With mode. Most of the calculators, the 30XS, at the top it'll tell you DEG, RAD. DEG will be degrees. RAD would be radians. So the graphing calculator, I don't think it cares which mode it's in. It understands. Most likely you're talking in degrees, but 4. Yeah, most of the trig is going 4. We're going to go 4 decimal places. Especially on the test, if you're not sure, I will give you a straightforward answer on number of decimal places. And I think that makes sense because, again, most of the rest of the tests you can ask any questions you want, but I think y'all have already figured out most of my answers are a question in and of themselves. I don't know if y'all picked up on that. 97.8375. Negative 97.8375. Second angle. Aha. That's cool. I learned something new. We have to go down a little farther into it, but the TI-30XS will do degrees, minutes, seconds.
I thought you already posted this.
I did, but we did it on the...
Oh, I could have sworn I've done it on this and you tell me how to do it. Wait, what button did you push again?
So second probability, second PRB.
Why are you laughing?
Yeah. I mean, for the most part, we hadn't had to worry about the mode being flipped around because for geometry, everything's in degrees. We don't talk about radians. Trig is really the first place we bring up radians. Negative 97, 50, 15. 50, 15, I had it flipped. Questions on this here for 15, 16, 17, 18? We feel comfortable from going to degrees, minutes, seconds, to degrees, or degrees to degrees, minutes, seconds? Awesome. All right, 19 or 20. 19. Now, 19 and 20 are going to be very similar. If they give you a point, especially these here, an ordered pair, and they want you to find all 6 trig functions, I'd put it on a grid. If they give you a sign value or they're trying to find all 6, we can use the theorems, or I can make a triangle. Because here, we can go through the laws, the properties using the unit circle. I can find that point. Because I'm going to go over negative 8/17 and go up to 15/17. Is that accurate on that scale? Well, no. But does that matter? No. Because all I've done is made a triangle. I've made a figure for myself to be able to figure out this here. Now the two sides of the triangle. One of them, I have it in a nice spot. The other one, the negative, or the 15/17, really is our height. Because that's our height. The negative 8/17 is our other side. Those are our two sides of the triangle. We feel good with this here. Now, the only thing we're missing is the hypotenuse. R is equal to 15/17 squared plus negative 8/17 squared. Now we could use Pythagorean's theorem, which is essentially the exact same thing, because we would take 15/17 squared, add it to negative 8/17 squared, find the sum of that and take the square root. And we're going to find out that it's 1. Because I think 15 squared plus 8 squared ends up being the same as 17 squared. So R is 1. Okay. Let's go. I'll just use blue. This. Sine. Sine is what over what? Opposite over the hypotenuse. Opposite over hypotenuse. Opposite over adjacent is tangent. So opposite over the hypotenuse. So that'd be 15/17 over all over 1, which is just 15/17. Cosine of theta. Adjacent, negative 8/17 over 1. Also, according to the unit circle, the x value of a point was the cosine, the y value is the sine. That's why we get those values straight back. Tangent. Two ways we can get at it. One, it is opposite over the adjacent. Tangent's also sine over cosine. Fraction on top. 15/17. Fraction on bottom, negative 8 negative 15/8. Questions on sine, cosine, tangent? Opposite over the hypotenuse. Adjacent. Yes. If you want to write that down, I'd write that down. Now, cosecant. If we keep put it in terms of our opposite adjacent hypotenuse, would be hypotenuse over opposite. Or cosecant, CSE is 1 over sine. So sine is 15 over 17. Cosecant is 17 over 15. We just flip it. Secant, 1 over cosine. So negative 17 over 8. And cotangent, 1 over tangent, we flip tangent. Negative 8 over 15. Now secant, cotangent, all we've got to do is flip the fraction and we get our value. The only time that that does not work, and that's not the final answer, is if we end up with a radical, a square root in the bottom of the fraction. If you end up with a radical square root in the bottom, 30xs, let the calculator do it for you. It'll fix it. But that's it. So really, once we get sine, cosine, tangent, we have secant, cosecant, cotangent. Flip, flip, flip. Questions on these here? Does putting it on the unit or our coordinate plane help figure that out? Most of this here, even 21 through 24, find all 6 angles. There's different ways to do this. 5 or 6. Don't. All right. Now, 5 pi over 6 with these here. We can look at the unit circle because pi over 6 is one of our nice ones. Well, 5 pi over 6, pi over 6, those there are most likely going to be on the unit circle. The ones that are pi's over 3, so pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. Those there, same with number pi over 6, probably going to show up on the unit circle. So we could grab the unit circle and see what is the x value. The x value would correspond to cosine. The y value would correspond to sine. Or, because if we looked at the unit circle, the y value would be positive 1/2, because we're in the second quadrant, sine is positive. Next I'm over in radian. Cosine of 5 pi over 6 is negative square root 3 over 2. Now for these here, I would definitely be using the 30xs because again, the 84 plus the graphing calculator is going to want to approximate the square root of 3. And do the same thing for tangent. Now out of all these here, cosecant's kind of nice. because cosecant's 1 over sine, the flip of sine, which would be 2 over 1 or just 2. Cosine, if we flipped it, it'd be negative 2 over square root of 3. We can't leave a radical in the bottom of a fraction. So dxs will rationalize it, negative 2 square root of 3 over 3. Same with cotangent. I have a feeling. Nope. It doesn't like that. Because it'd be 3 over negative square root of 3, which is negative square root of 3. Questions on that there? Yeah. I think I might have done 3 over negative square root of 3. Negatives placement doesn't matter. Flip it and then let the calculator do it if there's a radical in the bottom. Because we can't. Now, the only rationale that I can come up with behind not leaving a radical in the bottom of a fraction is because fractions are really just saying we're dividing two numbers. Radicals, especially the square root of 3, is irrational. It's a non-repeating, non-terminating decimal. We don't want to leave an irrational number in the bottom of a fraction. That's the only rationale I can get behind that. Any other questions on 21 through 24? We feel good with 21 through 24. Because I mean, even in the most parts with, if we're using the unit circle, we find the coterminal angle for negative 5 pi over 3, which is going to be pi over 3. Then we'd use the unit circle to find sine, cosine. We can find tangent, sine over cosine, secant, cosecant, cotangent. Questions on 25 through 32? We can, yes. Tangent, sine, cosine, 25, 27, 29, 31, I think y'all feel comfortable with. Secant. Secant's 1 over what? So 1 over cosine of our angle. And the correct answer is not negative 1.0029. Why? This is in radians, but what did it tell us the angle was in degrees? So it's actually 1.4718. Because the calculator was in radians, it needs to be in degrees. Now, one thing I will say, especially for this here, these, so many questions, it's asking us for the measure and to round to 4 decimal places, yes? Will both calculators round to 4? Yeah, it doesn't matter which one we have, yes? So time-wise, it might be easier to have one set in radians, one set in degrees, but you can switch back and forth. It's just making sure. Well, so 40 or 26, yes, is in degrees. We go to 28. Because 2 pi over 15, that is in radians. So that means we have to go back over to mode, switch it to radians. Now it is cotangent, which would be 1 over tangent of 2 pi over 15, which is 2.2460. Now, the answers we get for this here will not have a radian or degree marker or any of that because it's not an actual degree of radian. As our answer is not. But what we're plugging in is going to be either degrees or radians. Questions on this here? Cosecant's 1 over sine. Cotangent's 1 over tangent. Secant's 1 over cosine. Questions on this here? Secant, SEC is 1 over cosine. Secant, yes. Yeah, because SEC feels like it should be sine, but it's actually cosine. CSC feels like it should be cosine, but it's actually sine. That's the only way I've kept them straight. S and C, C and S. Tangent, cotangent, yeah. That page is out of order. No, wait. 33, 30. What's the next set? 35. Yeah, given a trig expression and theta is, or given a theta is acute angle. Okay, I don't know where those went. And I think I missed that the last time. Really, those there, those are not bad. Let's look at 35. Because again, with these here, there's different ways we can go about doing these. But the best thing I would do with any of these here, even 33, 34, set the triangle up. Set the triangle up. Now, we're wanting to find all 6 trig functions, really 5. They give us 1. And we want to find the other 5. Now, out of any of them that they give us, we'll already have a second one. We just need to find the other 4. Because cosecant, CSC, is the same as 1 over sine. So sine is 7 over 25. Tangent, secant, cotangent. Because they say find all 6. Well, they gave us 1, so we're really having to find 5. But whichever one they give us, we have its other. So if we're given sine, we have cosecant. If we're given cosine, we have secant. If we're given tangent, we do have cotangent. Because it's just the flip of those. Or vice versa. Since they gave us cosecant, we know sine is 7 over 25. The whole part about the angle being acute means it's just in quadrant 1. It's just a triangle. Now sine's what over what? Opposite over the hypotenuse. So the opposite side is 7. The hypotenuse is... Now all we're missing is the adjacent. Pythagorean theorem, a squared plus c squared equals c squared. 7 squared is 49. 25 squared, I think, is 625, but I'm wrong. Might be wrong. Nope. Six. 625 minus 49. And take the square root of plus or minus 24. But since our angle is acute, we're in the first quadrant, it's going to be positive. That was just to find the adjacent. Because once we have the triangle set up, everything else is going to fall in line. Questions on how we found or finished out the triangle? Because the reason we need it is if we look at cosine, cosine's what? Adjacent over the... Well, I have the adjacent side now. Yes, it is. Over 25. Tangents opposite over adjacent, which would be 7 over 24. Questions on how we had now got cosine and tangent? We feel good getting those. Yes? Secant. Hypotenuse over adjacent, or just flip of cosine, which would be 25 over 24, and cotangent is the flip of tangent, and we have the rest. So really, once we get the triangle set up with 33, 34, 35, the triangle tells us everything else. Questions on those there? Well, I don't remember how many we have left. We'll finish this tomorrow. The rest of it's going to go pretty quickly.